Sweet. All right. Let's start with part 1.
Okay. I'll read it.
Okay.
What is the confidence interval?
That's a good question.
It is a commonly used interval estimator. Is that what you got, Eddie? Eddie, did you do it?
Yeah, I did it.
Okay.
I put it's a confidence interval in between a population parameter, or estimate the population parameter.
So that confidence interval is just numbers that estimate the population parameter?
Mm-hmm.
So they'll give you like 90%, 95%, 99%, and that's your confidence interval.
Okay.
And then you estimate where that would be.
Okay.
And you use the applet.
Oh, you do?
Mm-hmm.
Yeah, and everything's in between, so you don't have to do left or right. It's everything's in between, and then if you put in like on the applet the 95, I can't remember what did it say. All that it was always.
90 is 1.645, 95% is 1.960, and 99 is 2.576.
Can you
Yes.
say that again?
Yeah.
90 is?
It's on the.
Which is also the one in question 5A.
Mm-hmm.
Is
okay.
90% is 1.645.
If you look at the homework at 4.1, it'll
Mhm.
have the most commonly used values for Z estimate.
Okay, so
And B is Z equals 1.960 for 95%.
1.960.
Mm-hmm.
Okay, and then 99.
Is 2.576.
So you're just plugging the 0.9 inside of the area?
Yeah,
Mm-hmm.
Okay, and then the center is?
right.
Then you read the Z score.
Perfect, got it. Okay. So we're on question 5D?
We're on. Are we
back to question
2?
Yeah, okay.
What is the margin of error in a confidence interval when estimating the population mean? This question is not asking for the formula, but rather the length it represents in the confidence interval. I put it gives an estimate of the variability in the responses.
Okay.
But in the answer it says the margin of error is half the width of the confidence interval. It is the distance between the point estimator and the one of the bounds of the interval. If you have a large margin of error, then your confidence interval will also be large. If you have a small margin of error, you'll have a small confidence interval.
Okay.
So.
And that's the formula you use?
The formula for number 3, assuming you know the standard deviation, what is the general formula for a confidence interval used to estimate the population mean? And it's x bar plus z with the standard deviation over the square root of n.
Mm-hmm.
Or x bar plus or minus m, which is what we're learning about.
Okay.
Margin of error.
Yeah.
That's the margin of error?
Mm-hmm. M is the margin of error.
Perfect. All right, I'll read 4. What are the assumptions for creating a confidence interval for a single mean with sigma known? I have no idea.
What is the assumption that creating? That is number 4.
Mm-hmm.
For a simple random sample was drawn from the population. Oh, there's 3 things that, and it's in a couple of the answers here. It's a simple random sample was drawn from the population.
Mm-hmm.
The distribution of the simple mean is normally distributed, and sigma is assumed to be known.
Okay, and those are the assumptions you always make when making
Right.
a confidence interval.
Right.
Cool. Okay. And then we did 5 all the way through C, right?
Yes.
So we're on D. So what happens with the z-score as this area in the middle under the normal curve increases? And it says the z-score also increases.
Yeah.
Score in the area in the middle under normal curve. Okay. Cool. Can you hear us, Marjorie? No? I haven't heard her.
Okay. So, can she hear us?
I don't know.
Are we on D?
Can you hear us, Marjorie?
Is she still even waiting for us? Like,
Oh, she lost volume and you guys can't hear me.
Oh.
Okay.
Can she hear us, though?
I just sent. I'm going to try on the iPad. Okay.
Let's just wait a minute, then.
Yeah, let's wait for her.
we're just waiting on her.
She's gone.
Hey, what'd y'all get on the homework quiz last week? 'Cause I got 2 wrong. I got the last one, and I think it was the second one.
On the homework quiz?
Yeah.
I think I got 1 wrong, and I couldn't get it right.
I got that one. I got them right, which I'm surprised because you guys are smarter than me.
No.
I hate math. This class is like my worst nightmare.
Oh, I feel you on that one.
Mm-hmm.
I'm actually good at math, just that biostats is not calculus, so I don't like it.
Oh, here's a question.
No, we can't hear you.
So the question for the quiz was, which one of the following best describes the notion of the significance level of a hypothesis test? And
What question was that?
number 2.
On last week's the homework quiz, let me look and see. Hold on.
Oh, I put type 1 error. And I think I put that because which one of the following best describes the notion of significance level of a hypothesis? I don't remember why I put that, actually.
Which of the following best describes the notion of the significance level of a I put type 1 error also.
Mm-hmm.
Was that just because, like, that's what the hypothesis test does? It proves a type 1 error?
I knew why I chose it last week, but I don't remember last week very well anymore.
Yeah.
It's been a long weekend.
What was the other one that you got wrong, Eddie?
Let's see.
I got question 4 wrong.
The number 10.
Number 10 is I got type 1 error because principle rejects the null hypothesis when it is true.
Which one I got?
So A, or whatever.
Mm-hmm.
And number 4, I put fail to reject
The null.
the null because the p-value is greater than the significance level. So the last one, like D.
Ah, that's why I got it wrong.
It was all in the wording. The first time I took it, I got that. Yeah, the first time I picked it, I think I put 1 also. And then when I'm like, well, how did I get that wrong? I sat there and looked at it forever, and it's always the words that throw me. I either skip over, I read it too fast, and it's tricky. And so I had to sit there and read it a couple times.
It'd be nice if they gave us 4 chances to take these.
Yeah. I'm just happy they give us 2, because usually if I miss one, I can like really think about it.
Oh yeah, and then you can figure it out usually.
Yeah, but I wish they would have done that with the exam, because there's a couple that I missed, and I'm like, I don't even know why I missed them.
Can you guys hear me now?
Yes, we can hear you.
Okay, I got it on my iPad. I don't know what's up with my laptop. All right.
Okay, let's
Did you
go
guys
back.
finish? Are you on the preparation still, or doing homework?
Yeah. No, we waited for you.
Okay.
Okay, so the preparation, we got to number 6 though, right?
We're on
D.
D, aren't we?
Oh, D. Oh, we did that where the z-score increases.
Okay.
All right, we're on 6.
And then 6 is the same answer as 4.
Okay.
Yes. Those 3.
Let's go to 7 then.
And then 7 what is the point estimate for the population mean, which is 541?
Just the same as the population, the students.
Yes.
Okay.
Okay, so this is where you use the math when it's create the 95% confidence interval for the population mean, show your work.
Mm-hmm.
So you take that population mean, which is the 541,
Yeah.
and you subtract it from your 0.196, because that's what you put into your area for the 95, the 0.95 on the applet. Where did my applet go?
So you subtract it from 1.960?
Yes.
To 95%.
Yeah.
Okay. And then that's the answer?
No. And then
That's only one side of it.
That's not even the whole one side, though. It's 541 minus 1.96 times 30 over the square root of 50, because you're doing 30. Where's 30, or is it 32?
30 is the standard deviation, right?
It's 32?
Yeah.
Millie, I need you to watch a movie with Brigham. I'm doing my group.
So you do the 541 minus the 1.96 times 32 over the square root of 50.
32 over the square root. Perfect. Okay. All right. The z-score. Oh, the z-score is the 1.960, right?
And then you have...
Okay.
Yeah.
Cool.
And then you have to do the same to the other side, but instead of minusing, you have to add.
Oh, you have to do the same thing again?
Yeah, so the formula is x bar.
Because you're doing it for the positive z-score and the negative z-score.
Yeah.
Oh, okay.
Yeah, so you're going to do the x bar negative z-score on one side and then x bar positive z-score on the other side.
Okay.
To find the margin.
Yeah.
50. Cool. So, 541. Did you guys get 2,439.42?
No.
Well, for one side.
No.
No? What did I do wrong?
No. What's your math say?
It's 541 minus 1.960 times 32. Oh, actually.
Over
the square root of 50.
Yeah.
I didn't do the square root of 50. Okay. And then 1.960. Is it 532.13?
Yeah.
Yes.
Okay, 532.13. And then it's just...
And then the same thing except for plussing.
And it's 549.87?
Yes.
Okay. Cool. That
So
makes sense.
Then the next one, it says, say the sample size changes to where n equals 100, compute at 95, which we already did, interval with the same point estimate. So all you're doing is changing your n. Yeah.
Okay, that makes sense. So the way we write this, do we write it in parentheses with a comma?
Yes.
Okay. Cool. That makes sense.
Yeah, like so the answer is 532.13, comma 549.87.
Okay. Got it. Sweet, that's not too bad, actually.
No, it's just another equation, right?
Yeah, it's kind of nice. Sweet. We are on 10?
10? Yeah.
I'd rather have this than figuring out the type 1 and type 2.
Oh, yeah.
Anytime.
How does a margin of error for 95% confidence interval of a sample size 50 compared to the margin error for 95 confident interval of a sample size 100?
And that's just that it gets smaller, because the larger you get, the more you take from a population, the smaller your margin will be.
Yeah, so your margin of error gets smaller when you have a larger sample size.
Okay, cool.
So the next one's a math problem where it says create a 90% confidence interval for the 50 students.
And compared to, these are all pretty simple. I can figure them out if I did them.
Yeah. It's not hard. It's just,
just math.
Yeah, it's just math.
Yeah.
Well, and knowing what to do for what question.
Yeah. Okay. Well, 11 seems pretty self-explanatory too.
So that's where you just put the 90 into the applet for your area.
Okay, and then you just do 50 under the square root. And
Yeah.
then
Yes.
for 12, you're just comparing. And
Yeah, because of between the 90% and 95%. The 13 is a little different math problem.
So is this where we use that formula with x bar plus or minus m?
This
Yes.
or
this is that finding n.
So the formula is n equals z standard distribution times the standard distribution over n.
Over m?
N.
And then all of that squared. The
all of it. Okay, so it's n equals z times standard distribution over m squared.
Right.
So, Catherine, this is the actual numbers right here.
Okay. Oh, I'm not looking at the thing. Okay, 1.9.
If this makes sense.
Yeah, it does. Times 32.
And in your calculator, you have to put in these parentheses.
At
least I did.
Yeah.
To get the... Okay, and then you guys, they totally rounded up the guy in the video to 158.
Always. It says there's never... Throughout the whole lesson, all the answers are going to be, like I did in the reading, I don't know if you guys do the reading assignment, like the problems within the reading assignment, but within the problems in the reading assignment, they kept saying that it has to be a whole number, and you always round it up. Even if it was 3.91, it turns into 3.92.
Really?
Yeah.
Cool.
That's because it's saying like, if you have 5.34 people and you have to feed them, then you just add up to like 6 people.
Yeah, because there's never a 0.4 of a person.
So you just round up to the next whole number?
Yes.
Yeah.
Okay. Cool.
Just so you can be within the margin of error.
Yeah. Sweet.
Okay. Let's do the homework.
That sounds
Okay. Oh my gosh, every time I shrink something down, it disappears.
Okay. Do you guys have that? I'll go ahead.
Let me pull it up. Mine just, let's see.
Yeah, I'm getting it really quick. All right.
Where is it? Hold on. Lesson 12 homework. Okay. Or lesson 10 homework. Okay.
Which
We're
of the
good.
following confidence levels will yield the narrowest confidence intervals for the same analysis?
Would that be 90?
90.
Deal the narrowest confidence interval is the smallest analysis.
Yeah, I would say 90.
90?
Yeah, because 90 would.
Why is it 90?
90, the narrowest, because if you put in the area on the applet, it's 1.6. If you put in 95, it's 1.9. So narrow, I would say, imagine narrowest would be smaller. So the 1.6 is smaller than the 1.9 and the 2.5 with the 99%.
That makes sense.
Okay.
Cool. All right, I'll read 2. A random sample of n equals 51 homes listed for sale in Madison County was collected. The 95% confidence interval for the true mean listing price was computed to be $225,000 to $341,800. Write a correct explanation for this result that would make sense to someone who has never had statistics.
Oh. A random sample of n, so n is 51. The confidence, okay, 95%, so you get the 1.96. Confidence interval.
So would it be that the actual price of the homes, like the actual prices are in between, or 95% of the actual prices of the homes are in between those two?
Yeah.
Between that interval?
Yeah.
Would that make sense?
Mm-hmm.
Yeah, random, yes.
Okay.
You got to get your own food. I'll read 3.
Okay.
Use the information in question 2 to answer this question. What is the probability that the true mean listing of homes in Madison County is between this and this? Okay. We're not solving for anything.
What is the probability of anything? I would say 95%.
No, this one is in the homework. This was a confusing one for me, and it's like it's 0 or 1.
Oh, that's right.
And I'm trying to find it so I can explain it because I know the answer, but I can't tell you why.
Is it 0 or 1 because it's fixed and it doesn't change? It says that in the textbook.
So in other words, it could be between those numbers, or it cannot.
Oh yeah, it's either correct or not correct. There's no like.
Yeah.
When I was watching the Cromer videos.
Yeah.
Either correct or not.
Kind of like when you flip a coin, you have 50% chance of getting tails.
Yeah.
So in other words, you have a mean of 1 or 0, which is you either do get a heads or you don't get a heads.
Okay. That makes sense.
Number 4. List the 3 requirements that should be met when computing a confidence interval for a mean with sigma known, and that goes back to the 3 that we did. The simple random sample was drawn from the population. The distribution of the sample mean is normally distributed, and sigma is assumed to be known.
Yes.
Okay. Cool.
Okay. Now 5.
I'll read. A school social worker wishes to estimate the mean amount of time each week that high school students spend with friends. She obtains a random sample of 1,175 high school students and finds that the mean weekly time spent with friends is 9.2 hours. The population standard deviation amount of time spent with friends is 6.7 hours. Use this information to answer questions 5 through 11. So I think we're going to do just a lot of comparing.
What is the point of estimate for this population?
No,
The point of estimate is 9.2 hours. Because it says high school students and finds that the mean weekly time spent with friends.
Hey, ladies, I'm doing my. You get your milk and go ask Addie or Millie. I'm doing my group, you guys.
Okay, so why is it 9.2?
It's 9.2 because it's asking you what the point estimate for the population mean is. So it's asking you what the mean is. So it's 9.2.
Cool. All right, that makes sense.
And then it says find the margin error for 90%. So you need to plug in the 0.90 and your applet where you get the 1.645. And that's when we need to do that, the formula.
Okay.
The long one.
So is it 1,175 minus the 1.645?
Yeah. It's first. Yes.
Hold on, let's see.
1.645, and then we have over. Where is it? The standard.
Standard deviation 6.7 over the square root of 1175.
Oh, this is times.
Oh, not 1175. What am I doing?
Yeah, I'm like, is it 6.7 or 9.2?
9.2 is the mean, not so it's.
Is this standard?
N is 1175. So the. Hold on.
The mean is, or the X bar is 9.2 then.
Yeah.
Okay, that makes sense.
Whoa. Okay, so down in the sample means is the 1.75.
So the X. Yeah. Yes, because the sample mean, it says a random sample of 1,175 high school students. So it's X is.
Oh shoot.
Hold on. What's X? X bar is.
Isn't X bar the 9.2 because it's the sample, random sample? Or
no, that's the mean.
That is X.
She thinks the system random sample of so the number of high school students is 1175. That's N.
Yeah.
And she thinks the random sample of that N, which is 9.2.
So was it 9.2 minus what?
1.645, yeah.
Oh, yeah. 1.645, and then times. Okay.
Okay, 9.2.
And then I got 8.88, basically.
Yeah, I got that too.
Is that what you guys got?
Mm-hmm.
What did you get?
I can't.
I got 8.878.
Mommy's doing her math.
Yeah.
Girls, I need your help with babysitting, please.
And then I got 9.52.
Thank you.
And yes, and then you have to add that.
Mm-hmm.
Which is, 9 equals 9.525. I don't do it.
522?
Yeah, 522. Yeah.
Okay.
Where are you guys?
So,
what do you? I'm. once we got that 8.878, is that the answer for 6?
Yeah, the answer is the. No. We're on 7, aren't we?
Okay, what did we get for 6?
Okay.
Did we skip 6? Hold
Did
on.
we skip 6?
Yeah, find the margin.
8.87, isn't that just the answer?
For 6?
No.
Let's see, 6, find the margin of error for the 90% confidence interval for the true mean hours
Oh.
spent.
We need to find both sides. We need to plus it now. The same question, the 9.2. Or did you already do that?
That's for 7.
So
We
number
never did
6. Find the margin of error for 90%.
No, but we need to do both sides to actually find the margin.
Well, yeah, but that's 7, 8, and 9. 6 is asking for something different.
It's asking for the margin of error.
So is it...
Oh, that's just ask. If we find both sides, then it's asking for what that number is. It
So
might
it's
be a 3. It might be
0.322.
a... Yeah. It just wants to know what's the in-between number, like what, or how many, what do you need to get to one side and what do you need to get to the other side? Does that make sense?
Yeah, actually.
Go
The
ask
mar-
your sisters.
If the answer in 6 is just the 1.645 times 6.7 over the square root of 1,175.
I'm lost on number 6.
So
Okay.
number 6, say our margins were, the redheaded guy gave the examples of like 77, okay? And if the margin of error was 3, then it would be 74 and 70 and 80. And your actual margin of error was 3. Does that make sense?
No.
Because it's 3 up from 77 and 3 down from 77.
So if you subtract the 9.52 minus the 8.88, you would get the answer to number 6.
Okay.
You do? Let's see. Hold on.
Or no, actually. The
No.
way that I got the answer by just doing the 1.645 times 6.7 over the square root of 1,175. That's how I got the answer for number 6.
Okay.
How did you get it?
So I did so it's asking for the margin of error for the 90% confidence interval.
Yeah.
So you plug that into the applet and you get 1.645.
Mm-hmm.
And then you multiply that times 6.7, which is the standard deviation over the sample size, the square root of the sample size. So it's over the square root of 1,175.
Okay. I want to do it so I can, like, figure it out in my, sorry.
That's okay.
No, you're fine, Donna.
Does that make sense, Eddie?
Yeah. That makes sense now.
6.7. Okay, got it.
Okay.
So that's just the formula, which is the m equals z estimate with standard deviation over the square root of n.
Yeah, the margin of error is just the z
Mm-hmm.
times standard deviation over square root of n.
All right. So we did 7.
8 and 9 are just plugging in the different z scores.
Find and interpret the 7 is 90%. Oh, I just need to do the math again.
Yeah.
Go away, honey.
Oh, I got that wrong. What did I do?
Which one are you doing?
I'm doing number 8.
Okay. I got 8.817.
Yeah, that's what it is, but I'm like, I must have done something wrong because that's not what I got.
The new Z-score?
8. Yeah, the Z-score is 1.960.
Mm-hmm.
So is it 9.2 minus 1.960 times 6.7 divided by the square root of 1175.
Mm-hmm.
Why is my calculator not doing this right?
Try doing
8.87.
the 6.7 divided by the square root of 175, or 1,175,
Okay. 2.
and then multiply that by 1.960. 960.
Oh, okay.
No.
Nine.
Here's a Mew, everyone. My daughter's obsessed. Okay. All right, Claire.
Okay, so it should be 9.2 minus 1.960 with the 6.7 over square root of 1175. Okay, I know, I understand the math. I'm just doing something wrong. What is the answer that you guys got?
I got 8.817.
Okay, and then on the other side?
I got 9.583.
Yeah.
Yep.
Good. And then the same thing
With 9.
9. 99. The 2.57 minus oh wait.
Two.
Times okay. Did you guys get the 4.17?
I got 8.696.
That's what I got.
Okay, what did I do wrong? You guys still doing the 9.2 minus? Oh, I haven't done both sides.
Yeah.
Yeah. Well, you guys first did the minus, the 9.2 minus the 2.57
6.
times. Where did I put 6? I put, yes.
6.576.
I missed a number. That's my problem.
And then times the 6.7 divided by the square root of
1175. Yeah.
And so for the other side, I got 99.704.
That's what I got too.
Okay.
It really screws you up when you miss a number. Stupid. over.
Are you ready for 10?
Yeah, let's move on.
Okay, what do you notice about the relationship between the level of confidence between 90, 95, and 99 and the width of the confidence interval?
I would say that it increases.
Yeah, as a level of confidence increases, interval width also increases.
Okay,
Totally.
cool. 11 says, suppose that a new study is being planned. What sample size would be required to obtain a 95% confidence interval with a margin error of 0.25 hours?
Would be required.
So is it 1.960
No.
plus or minus 0.25?
95% is 1.9.
It'll be 1.960.
Mm-hmm.
The standard deviation of 6.7.
Is this the N question? Solving for N?
Yeah.
Oh.
Okay.
Oh.
Got it.
0.25
So it's the z-score
squared.
times, isn't it? It's the big parentheses.
Yeah, so Z times standard deviation over M,
No, go away.
right?
Yep.
Okay, so what do
Okay.
you, suppose it is
They don't want to see it, N.
margin. What is 0.25 hours?
Okay,
Suppose a new study is being planned.
2.576 times.
I got 2,759.2.
And the math that you did was the 1.960 times 6.7
Mm-hmm.
No.
divided by, what did I just,
0.25.
0.25, and that's squared, right?
Mm-hmm. So, how do you
Hold
know
on,
that we're using the N formula, Eddie?
because it wants to know a specific margin of error.
And it's asking for what sample size would be required. So N is the sample size. That
Okay,
to me
go-
makes sense.
Sorry, you guys. Can you go through that, Donna, since you just asked, or someone, the math again? The 1.9.
Yes, 1.960 times 6.7. So the 1.960 is the 95% in your applet.
Yeah. And
Times
where'd you get the sigma? The
Standard deviation is in the problem.
Yeah, it's up in that other problem where 6.7 was the standard deviation times spent with friends.
Got it. Okay. The 6.7. And then it was over
0.25.
0.25 hours.
And that's square rooted. Or
That's squared.
yeah, square. Square root 0.25, and then parentheses, and then that. Okay. What'd you guys get with that one?
I got 2,759.2. You guys said they round up, so I'm guessing it's 2,760.
Yeah.
Okay. Cool.
Did you get that, Marjorie?
No. What am I want to find out what I'm doing with my math wrong.
Okay. So it's asking for. My thing just skipped up. Okay. Suppose a new study is being planned. What sample size would be required? So if you're doing 95%, you're at the 1.960 times your standard deviation of 6.7 over 0.25. So you times.
Oh,
You got it?
What's it called? Anyway, I added something with the 0.25. Okay, never mind. I squared it, or yeah. Anyway. Okay, I know what to do now.
Okay. Number 12. What is a point estimate for the population mean?
What is it asking for? Point
Sorry,
estimate.
Oh, isn't that just the mean?
Oh, that's just the mean. Yes. So.
Oh, let's see. Where is it? I'm looking at a different problem.
0.16, right?
Yeah.
Okay.
0.16. Find the margin of error for a 95% confident interval for the mean BAC. So 95%.
95 is 1.960.
1.960 minus.
Don't you just multiply that by the standard deviation over the square root of n?
Yeah, the standard deviation was. Where is it?
Oh, shoot.
It's awesome.
How are you? Can I call you back in a little bit? Okay, I love you. Okay, bye. Oh. Woo.
So the standard deviation over. What are we doing? 1.960 times 0.08 over 600?
Over the square root of 600.
Oh, square root. Okay, that's what I was missing. Sorry.
Times 1 point. Did you get 0.006?
0.006 is what I got.
Okay.
Oh, you guys. Okay, we've got the 1.960.
It's these equations. There's so many different types. Like you're trying to figure out which one to use. That's where it all gets screwy with me. Is I'm trying to figure out what equation to use.
I see this one. Okay, so with a sigma, the standard deviation is the let's see, the 6.7. Is that still it?
No.
No.
It's the standard deviation. Is that what you're looking for?
Well, are we doing for 11? Are we doing the 1.960 times the standard deviation over the square root sample means?
No, we're doing
but
the margin of error, which is 0.25.
Okay.
Don't you love summertime?
I do like having my kids around. She just has a poopy diaper. I need to try to get my 11-year-old to change it. She's walking around with cough drops.
How many kids do you have?
5.
5. What are their ages?
11 to 2.
That's always fun.
Yeah.
That was my age span. I had a 10-year gap between my oldest and my youngest.
There's a 10-year gap between my younger brother and I. We're 5 kids, though.
Yeah.
There's 14 years in my family, but there's 9 kids.
9.
Okay. Okay. Ladies and gentlemen, 11. What did you guys do for the math?
Okay.
That one.
I'll explain it to you. So, it's asking for the margin of error. Or no, is that? Are we on 11?
11 or 12?
We're on 12.
We jumped.
No,
okay.
We're on 13 actually.
Yes,
okay,
we're on 13.
Got it. 13. Okay. A margin of error. Yeah, you do the 0.160 times the standard deviation over the square root of the sample size.
Yes.
That's the math for it.
That is the math, yeah.
Okay.
Over the margin
And-
of error.
Oh, yeah, over the M. Not N. M.
Yeah.
Okay. Yeah, that makes a big difference.
And then square root everything. Or not square root, square.
Oh,
Wait,
yeah.
for number 13?
No, for
No,
13 you don't do that.
Not
No,
for
for
that
no.
one.
No, not for that one. This one you're just doing the 1.960 times point. Yeah, 0.08 over the square root of 600.
Yeah.
Was Donna right? The 0.00026?
It's 0.006.
That's what I got.
Where did I get the 26?
You have 1.960 times 0.08 divided by the square root of 600.
Oh, I didn't square root the 600.
It's always something, that little thing that I do the same thing.
Oh, I do this all the time. It's ridiculous. My sister-in-law the other day said the word donkulous, and I loved it.
Isn't that in like a Shrek movie or something like that?
I think so.
She probably got it from that. Oh, no, I didn't put a point in. Okay. Anyway. All right. Now I got it. Yes, I got it. Okay. Just say, you guys go on. I'm just telling my 11-year-old she has to change a poopy diaper.
Right.
Okay, so number 14.
Addie, honey, I need you to change Phoebe's diaper. She's got poo-poos. The diapers are in the closet.
Compute or interpret the 95% confidence interval of the mean BAC. Compute and interpret the 95%. Is that the one that you're thinking of, Eddie?
The point estimate. The point estimate is the big one with the parentheses on both sides.
Yeah, so that's it. Oh, it is?
Well, that's my notes I took. Point estimate is the plus or minus, and it's this one, that like when you have the parentheses on both sides, and then you needed what? Pull it. I have to help.
Okay.
So what is X bar here?
So are we still on 14? Compute the interpret. Okay.
Yeah, we're on 14.
Okay. Compute and interpret the 95 confidence interval of the mean BAC.
Aren't we just doing the regular formula?
So what would the X bar be? Let me look at the question again.
There is no X bar.
So is this the one that we're going to figure out are we trying to figure out the mean? Because it's asking for
the mean, but how do we get the mean from if we don't have an X bar?
But we can do the z-score with the standard deviation over the square root of n. So if you do 95, which is 1.960 times, what's the standard deviation?
0.08.
0.08 over the square root. Didn't we just do this one, though? Yeah, we just did that. That was number 13.
I just looked at the answer, and it's different. So I don't know. It's in parentheses.
Okay, let's see. So let's try this again. It's going to be, what's X bar though?
Is it 0.16? I think 0.16 is X bar.
Okay, so let's try that. 0.16 minus 1.60 times 0.08 over square root of 600. Maybe that's it. Let's see.
There we go. Yeah, that's right.
Okay.
6 minus 1.960 times 0.08
Yep, that's right.
divided by the square root of 600. Oh, I just did something, my math wrong. Okay, 0.6 minus 1.960 times divided by, what did you get?
I got 1.5 or 0.154.
Yeah, I got that.
0.166.
Okay, so then I just need to go back in and do addition. 0.16. Okay, I got that.
Okay.
That was 14. Um,
15.
15. Assume you decide to randomly sample 1,200 records instead. And by some strange twist of fate, you get the same sample mean of 0.16. What is the 95 confidence interval of the mean BAC? What is the interpretation? So do you see the square root of
the 1,200?
1,200?
Yeah.
And that would be 15. I got 1.65.
Tell me the math you're doing, Donna.
Okay, so for 15, it's the same. Did you listen to the 14 one?
It's the bigger parentheses, the 1.6 minus the 1.60 times.
No, 1.960 times.
Yeah.
Okay, 0.08 over the square root of 600. That's for 14. And for 15, all they're asking you to do a change is your sample. So you're going to take that same equation and put 1,200 in instead of the 600.
Okay, 1.6 minus the 1.69 or 960. Yeah, 960 times the 0.08, right?
Yeah. Mm-hmm.
Over the square, and then here we change the sample to 1,200. And did you guys put parentheses around this whole thing?
No.
No.
Okay, I got the 1.595.
I got 1.56 comma 0.156 comma 0.165.
65.
Yeah, because you did the plus and the minus.
Yeah.
Okay.
0.155. So it says we're 95% confident that the true mean BAC is between 1.55 and 0.165. Okay. Number 16.
What do you notice about the relationship between the sample size and the width of the confidence interval based on questions 10 and 11? I would say that as your sample size increases, your width decreases?
Yeah. Because remember, it goes back to that, is it the law of large numbers? The more you sample, the less...
Yeah.
The closer it gets.
Yeah. Mm-hmm.
Yes.
Okay. Cool.
So, what as sample size increases, confidence interval decreases?
Yeah, so the sample size increases, the interval width decreases.
Okay.
17.
You want to read it?
Sure. The assertion in the NHTSA is that the true population mean, BAC, is mean of 159 based on your confidence intervals. Would you agree with that assertion?
Yeah. Right? Because it's in between the 1.156 and 0.165.
Yeah, it lies between the intervals.
Yeah.
So the answer says, although we cannot be certain of the mean without examining the entire population, the value does lie within all of our intervals. So although we cannot be certain it is exactly equal to 0.159, we can see that it is within the range of possible values, and it is possible that it is 0.159.
Cool.
Just as long as it falls between the numbers you calculate, it's a possibility.
Yeah. Okay. 18 says, suppose that a new study is being planned. What sample size would be required to obtain a 95% confidence interval with a margin of error of 0.002? So that's the N formula, right? Because we're looking for the sample size.
Yes.
Yeah. So that's the Z times standard deviation over margin of error squared.
Yeah.
18.
So it is
Z is what?
0.196 times.
What was the standard deviation? Was 0.08?
Yeah. Yeah.
0.08 and
The
M. What is M?
Oh, it gives it to us in the question. It's 0.002.
0.002. Okay.
And this is all squared, right?
Right.
Is that 6147?
Hold on. Times 0.08. 0.002. I got 6,147. Did you get that, Eddie?
0.002.
Yeah.
Okay.
Times. What did you get?
I got 6,147.
Oh, I did something completely wrong. 1.960 times 0.08 divided by 0.002. Is that what it was?
Yeah.
Yeah.
And then you square all of that.
Which number are you guys on?
18.
Yeah.
18.
What is your answer
And so-
for that equation? The 1.960 times 0.08 divided by
78.4 is what I got, and then I squared 78.4.
times 78.4. Oh, okay. I don't know why what I did, but yes, you're right.
Okay.
Well, I knew you were right. I don't know why I was wrong.
All right.
Okay.
Let's do 19. We have two more guys.
Yay. We typically want to get... Oh, go ahead. You go ahead, Marjorie.
We typically want to get the best estimate possible. Why don't we simply compute 100% confidence interval for the mean?
Well, that one is, you would have to get information from the entire population.
Yeah, and so often you're not able to get 100% of that population.
Yeah, that makes sense.
Okay, number 20. Which of the following explanations describes the correct way of interpreting a 95% confidence interval? Choose all that apply. There is a 95% probability or chance that the true mean is between the lower and upper bounds. We are 95% confident that the true mean is between the lower and upper bounds. Approximately 95% of all 95% confidence intervals would contain the true mean, and none of the above. Well,
I say it's the number 2, the between the lower and the upper bounds, that it's touching in both.
Well, it says that it's 2 and 3, and it's kind of saying the same thing, but 3 is just saying it really wordy.
Apparently, yeah, I mean, I guess 3 is just saying that anywhere in between that interval, there is a possibility of the true mean being in there, 95% of the time. I can see that.
Okay.
All right.
So you guys think 2 and 3 for that one?
Yeah, it's 2
Yeah.
and
Or just...
2 and 3.
All right.
All right.
Are we ready to go to the homework?
Quiz? Yeah.
Let me go to that. Oh, I always forget it's right on the same link.
Okay.
Uh-oh. Why did it tell me that? Quiz. Oh, my computer is being so slow.
Group.
Hold on just a second. Why is it doing that?
Okay. Group meeting quiz, 10.
There's 14 questions. Or 12, technically.
Oh, yeah, 12. Whoops. It didn't ask me my first 2 questions.
It didn't?
Did you click on the homework?
Oh, I did the wrong quiz. Let me get out of it.
You just it'll still let you finish it because I've done that before and it'll just show in progress.
Okay, I'm just going to get out of it. If not, I'll have to email the teacher.
Or bring up a new browser.
Yeah, I'm not stressed about that. Okay, we're a homework quiz, right?
No, group meeting quiz.
Group.
Oh, that's where it took me to the wrong place. Okay.
Interval for standard deviation is sigma is that and n is that. Okay.
Why are you required to work together? Find the margin of error for 90%. Whoa.
Girls, will you please come play with Phoebe while I'm finishing this up?
50.
Are we ready to start on 3?
Yep.
Okay. Not round until your calculation is complete. Please remember to round to 3 decimal places. Okay. So find the margin of error for a 90% confidence interval when the standard deviation is 50 and n equals 25.
So 1.96.
The margin of error. That's the 1.645 times the standard deviation over the square root of the
Sample
n.
size.
Yep.
I got 19.6.
So,
I am going 10 times 1.6. I got 16.45.
Okay, what am I doing different? 90? I have 90.
11.
Oh, I did the wrong number. Hold on. 1.6.
What'd you get, Eddie?
11.406.
Did you do the right one? 90 is 1.645.
I did this.
Sorry, I put a wrong number there.
Okay.
16.45.
Okay.
What did you get? What was the answer?
16.45.
I did something completely wrong.
1645?
Oh, I didn't divide. 16.45?
Mm-hmm.
Yeah.
Okay. I times it instead of divided. Okay.
Okay. X bar, or let's see, it says, which of the following statements is true? Sigma squared is an interval estimator of sample, or X bar.
Mean.
X bar is a point of estimator of the mean. The mean is a point estimator of X bar. And sigma is an interval estimator of sigma squared. I'd say it's C.
So the mean is a point estimator for X bar?
Mm-hmm. Or X bar is the point estimator of the mean. I think it's one of those. I think it's X bar is the point estimator.
Oh, let's see. Was that in our chapter, you think? I'm like trying to see.
Well, like when it asks for the point estimator, it's usually asking for X bar, and then we just get the mean. That's usually what we write down, right?
Well, wouldn't it be C then?
Is it C? It's. I think it's B or C.
Because they always give you the mean.
Yeah, they give us the mean.
And they make you put it in for X bar.
So is it C?
We can try C.
That one's confusing to me. It's true.
Because for what we use, X bar is our mean.
Yeah. Okay. But let's do that.
We're doing C.
We're doing C, yeah.
Okay. Gina wants to construct a 95% confidence interval for the GMAT scores. She knows a standard deviation equals 113. She collects a simple random sample size of n, which equals 64, and computes the mean X bar 526. What is the point estimate for that? And that is the z-score, let's see,
The mean.
which percent? 95%?
It's
For the mean. Yeah.
so
That's the times over, like the same thing we just did, isn't it? Oh, no, that was margin of error.
Isn't point estimate just like the mean? Or no?
No, it's not. It's an equation. It's let's see, we're doing 95%. It's the 0.960 times the sigma over the, let's see, oh, we have another number here. Isn't it the one with the both parentheses on both sides?
If it is, it's the 526 minus 1.960 times 113 over square root of 64.
What did we do for question 12 on the homework?
Okay, let's see. Hold on.
12. I didn't write numbers next to mine. I should have.
Oh, I didn't write it down either.
Did anyone write down the...
I'm looking for it.
Which one?
For 12 on the homework, did anyone write down the work for that?
Well,
Point.
let's see.
Oh,
Let's see. I think it's the point
it's just the mean.
960.
Which is
60. Well, the mean is the 526.
So that's the answer.
But I have a note here in my notes from just watching the videos that when you do the point estimate, plus or minus, or it's the 1.960 times the, let me see, the 113 over square root of, what is that?
I don't know.
Over
Well,
the
on the
n.
homework, it asks the same question, and it's just the mean.
The mean that time?
Oh, well, that's asking for the point estimate of the population mean, and this one is asking for the true GMAT score.
Addie, please come and watch Phoebe.
Yeah, so I think 5 goes with question 4.
Let's go.
Question what?
4. Quiz.
Yeah,
Okay,
so you
when I did the
526.
Yeah.
We can always change it if it's not.
Yeah. What is the margin of error for 90%? Go ahead.
Oh, I just did the let's see if you guys can see it. Just that 1 point, and I just did the math for it. But let's just go with that for right now, and then we can come back and do a formula if we need to.
All right. So let's do number 6. So it's going to be 1.96
Yeah.
Times
What
One-
Marjorie did was
the mean.
She did the margin of error.
Yeah,
Margin of error.
that's the equation for the margin of error. That's what we're doing right now, right?
So that's the answer for question 6.
The 27 point, this, what I was doing here, if you guys
Yeah.
can see.
1.960 times 1, yeah.
The,
15.
It's 20. Did you get
no, go away. Go away.
7.685?
27.685. Yeah. Go away.
Yep. Okay. That's the answer number 6.
So that's when you're trying to figure out the margin of error.
Yeah.
Okay. Ooh, we get 0.5 points for this one. Okay, now we have to do the confidence intervals and put both the top
What
and
is
the upper and the lower.
Yeah.
So the longer equation.
So for the lower, I got 498.315.
Oh, okay. I didn't even start yet. 426.
Will someone just do the upper then, the plus?
Which is the upper two. Yeah. Make sure you guys are done.
What did you get for the
For the
equation?
lower, I got, or the equation or the answer?
The answer?
I got 498.315.
Oh, I did 61 and not 64. Yeah, 498.315.
Tell us, what was the lower, Catherine, and the upper?
498.315. And the upper is...
Here, just a second. I didn't get the lower. 498.315
315.
for the lower. What?
Yeah.
315.
And
Okay,
the upper,
and the upper
is 553.685.
And you just separate it with a
Okay.
comma, right?
Mm-hmm. Well, you're just writing down the numbers on here.
Oh, what is the lower limit? So we're not doing...
Yeah,
that
well,
one.
one of them asks you for lower, and then the next one asks you for the upper.
Oh, okay. Well,
Yeah.
that would
7
help.
and 8.
553.685. Okay.
The confidence interval if Gina increased the sample size. Well, it would decrease.
Yeah.
Number 9 is decrease.
And then number 10 is increase.
Okay. Increase.
Yep.
Okay. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the whole number. Okay. So, we need 95, which I already have, is 1.96.
Oh, so we're doing the n equals formula.
Yes. So Z is the 1.960 times 400.
Standard deviation. Yeah, 400.
400 over
50
50. Okay.
squared.
Yeah. 1.960 times
60 times 400
That'd be 111.
over
What did you get,
50.
Catherine?
I got 245.862.
Yes, that's what I got too.
Did you get that, Eddie?
But we need to round it to the nearest whole number.
How did you get that?
So it's 246.
246. What did you say, Eddie?
246.
Make sure our other ones. Okay, other ones are good.
Okay, so this one is a 1.960 times 400 divided by 50 squared.
And we're just doing 246.
Yeah.
Yeah.
Okay. Everyone got it?
Mhm.
Yep. Okay. The mean salary actuaries is mu equals 100,000. The standard deviation of sigma is 36. Blah blah. You are interested to know the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with level of sigma area of 0.05.
So, what is the lower
Okay.
limit of the 95 confidence interval? Right,
Okay,
so
you
it
got the
is-
sample means of, oh, n is 36. Okay.
What math are
95.
you guys doing for this?
What is the lower
Which
limit?
one?
You're going to do the long one, but you're going to do the
long
negative
one.
side.
Top.
Well, you have to do the upper limit too.
Yeah. 960
Yeah.
minus, oh, hold on.
Isn't it 111,000 minus?
Yeah, yes, no. Hold on. Yeah, minus, what's the z?
It's
What's x?
111,000 minus
The
1.96
You can
times 0.05 over the square root of 36.
So you did 111,000 minus the 1.96.
Yeah.
And then it's 36,730 over the square root of 36, right?
Uh-huh.
Okay.
0.05 over the square root of 36.
0.05?
Isn't standard? Oh no, that's not standard deviation.
Yeah.
36,730. Yeah, you're right.
Okay, times 36,730 over.
Did I get I got negative.
Well, what are we over? Oh, we're over the area, or are we? Oh no, we're over the n.
Mm-hmm.
And is that?
I got
is
a
it
positive
square?
number for
Yes.
What did you get?
I got 99,001 point. So
What
it's
did I do?
99,002.
What did I do? I did. Oh, hold on.
Okay, I just did the upper.
For the upper, I got 122,999.
Yeah,
Okay.
I got that.
122,998. Are we rounding it?
Yeah, it's near.
Whole number.
What did
Nine.
Can you guys tell me the
for-
lower number?
Okay, so the lower is 99002.
And 002, and the upper was 122,999.
Yeah.
122,999
Yeah.
for the upper.
Right.
Yes. What were you asking, Eddie?
You said 99,002, right?
Mm-hmm.
And what was the upper limit?
The upper is 122,999.
I will be so happy when this class is got done. Oh my gosh.
14 is all of the above.
Huh?
14 is all of the above.
Yeah, I think so.
Who's turning it in first?
I'll do it first
Oh.
and we'll see what happens.
Okay.
You guys just put all of the above?
Yeah.
Yeah.
14. All right, all right.
I'm going to
Clicking
submit
it?
it and see.
Okay. I'm thinking
We missed one.
Which one did we
Um,
miss?
We missed number 4. That's the one we were doing the
that's the
following
one that
statement.
I think
through.
I think
you
it's
have to
B.
do the. No, let's see. Oh,
It's no
number
math.
4?
It's just answering a question. Yeah.
Okay.
There's no math on it.
So should we go for the X bar this time?
Yeah.
The X bar is the point estimate of mu.
That's what I thought it was.
Okay,
Yeah.
will
Okay.
someone go through the answers with me before we submit again?
Yeah.
Someone submit
Okay.
it. Go ahead and submit it, and then someone else can help me.
Yeah.
I'll
Well,
submit it, and
okay.
then before you through all the answers, so
Yep.
so I don't have to get it over again. Let's just wait.
Okay, hold on. You want me? So you want me to do it again?
No,
No.
we got 100%. Okay, now we were just saying don't go through all the answers because I might need you to go through all the answers again.
Okay. So,
But we got
question
100%.
Hold on just a second. I'm pulling it up again.
3. Okay.
True. Number 3 was
16.45.
oops, 16.45.
Okay, then it's B.
Okay.
Then 526.
Okay.
Then 27.685.
Okay.
498.315.
Okay.
553.685.
Okay.
That's decrease. Then increase.
Okay.
Then 246.
Okay.
Then 99002.
99022.
002.
99002.
Yeah.
That's for number 12, right?
And that is for number 12, yes.
Okay. Number 13.
122999.
Okay. And then all of the
14
above.
is all the above, yeah.
Okay.
Sweet.
Well,
Awesome.
I at least can get my head wrapped around this instead of, I don't know, the null I'm still needing to do some reviewing.
Yeah.
All right, guys.
All right. Well, see you guys next Wednesday.
Thank you.
Okay.
Yeah.
Bye, you guys.